Welcome everyone. This is going to be the first of many videos for Chemistry 1342, the second semester general chemistry. Got a lot of topics to cover in this semester, so let's just get right into it. First chapter we're going to be talking about is going to be dealing with liquids and intermolecular forces. So what are intermolecular forces? Intermolecular forces are forces that are related with attractive or repulsive forces between atoms and molecules that are not bonded together, right? We've talked about in the first semester of general chemistry, covalent bonds, ionic bonds, metallic bonds, things of that nature, right? Here we're talking about interactions between molecules and atoms that aren't bonding type interactions, okay? These intermolecular forces are very important. Understanding intermolecular forces and being able to kind of predict what type of intermolecular forces exist and occur and the strength of those forces is used for all sorts of type of research, including things like creating new storage systems for hydrogen fuel cells, right? If you want to store hydrogen gas, you prefer not to store it as a condensed or compressed gas in a can. It's very dangerous, right? You'd rather essentially store it in something like a sponge, if you will, right? Where it's not a high pressure system, right, for storing that gas. But you need a certain ideal binding range for that hydrogen gas in order for the gas to stay stuck to your sponge, but not stuck enough to where you can't get it out to use it as a fuel, right? In drug design, any drug that is trying to be designed often starts with modeling the intermolecular forces in some protein that the drug's trying to bind to determine what type of molecule, what type of structure will be able to bind to that drug. Okay. So intermolecular forces are very weak forces compared to the strong intramolecular forces, right? Things like covalent bonds are significantly stronger than your intermolecular forces. Okay. Intra, again, is between molecule, intra is within a molecule, inter is between molecules. Okay. These intermolecular forces play a strong role in determining the physical states of atoms and molecules at different temperatures. Okay. For example, right at room temperature, you have things like chlorine, bromine, and iodine exist as a gas, a liquid, or a solid. Okay. Right. These right, the structure of the molecules, right, just two atoms covalently bonded together, very similar between them, but the intermolecular forces are different between them, and you go from a gas to a liquid to a solid. Just as a reminder, right, gases, right, can fill a container that they're in. They don't really have a set shape. They just expand to fill whatever container they're in. They're easily compressible. They flow through space and diffuse very easily, right? Liquids, right, will also fill kind of the shape of the container they're in, but they will not expand, right, to fill that container. Liquids aren't really compressible, just like solids, right, but they do flow. Things can diffuse within a liquid, right? And then solids, right, very rigid, right, are not compressible, don't flow, don't diffuse, things like that, right? Okay. Just summary again of the properties of solids, liquids, and gases, right, in terms of how they retain their shape and how compressible they are and things of that nature, right? And we'll see as we talk about intermolecular forces, right, the relationship between the properties of these phases of state, right, solid, liquid, and gas phases, and the strength of intermolecular forces. Okay. Right, and the relationship is generally related to kind of this table here, in which, right, every atom, every molecule has some amount of kinetic energy, right? Some type of translational energy, vibrational energy, rotational energy, right? Some type of kinetic energy, right? Some thermal motion that's occurring, right? But in each one of these, in a given system, right, there's also attractive forces, intermolecular forces or attractive forces, And so depending on the relative strength of your attractive intermolecular forces and your kinetic energy will determine the phase of your system, right? So gases have a lot more kinetic energy than they do this intermolecular attraction energy, okay? Liquids, they're around similar, right? Because in liquids, you have enough kinetic energy that the molecules can move around, but not enough that it breaks them fully apart. Right? And then in solids, your attractive forces are significantly stronger than your kinetic energy, right? So that molecules aren't able to move freely. They're stuck in some rigid position because of these strong intermolecular attractions. Okay. Example of this, right? We look at kind of melting points and boiling points for different compounds, right? Things that are covalently bonded, right? Chemical bonds, ionic, covalent, metallic, right? Have very high melting and boiling points, right? Because they're very strong attractions between the different atoms and molecules, right? Intermolecular forces are a lot weaker than that, okay? But you can still have a wide range of intermolecular forces, right? Look here at nitrogen gas to say like hydrogen fluoride, okay? You have melting points that differ by, and boiling points that differ by over 100 to 200 Kelvin, right? Which is over 100, 200 degrees Celsius, right? And so the strength of these intermolecular interactions very much determines these melting points, these boiling points, and what phases your atoms or molecules will exist in at a given temperature. Okay. To wrap up this video, right, just getting a summary, right, for your intermolecular forces, right, if you have strong intermolecular forces, okay, that means as a liquid, for example, it's going to have, or as a substance in general, it will have very high melting points, right, so very high temperature in which it goes from a solid to a liquid, right, same with very high boiling points, the stronger the intermolecular forces, right, in the liquid phase, it will be more viscous, right, viscosity is related with how easily the liquid flows or doesn't flow, right? Think of like water versus like tar or something, right? Right, if something has very weak intermolecular forces, okay, that means you have very low melting points, very low boiling points, very low viscosity, right? And other such things, right? And these intermolecular forces, as we'll talk about more in chapter 13, okay, play a very big role in the solubility of stuff. What dissolves and what is related with intermolecular forces. This is related to what's called like dissolves like kind of phrase here, right? And so in the next video, we'll start talking about what are these intermolecular forces that determine the physical states of molecules at a given temperature.